In this video, I'm going to show you how to get your data from your experiment and then analyze it following these instructions here, which are also in the assignment instructions. So for this one, I'm going to use a demo file, which is some data I actually did collect. And if we open this up here, it's going to open up in Excel. And this was a study that was similar to some of the ones you guys did, in which I had participants take a scale on something called intrinsic school motivation or intrinsic academic motivation. And then I also have some information about their gender, age, race, and GPA, which is going to be our dependent variable. So here, the scale, if you look at the top bars here, you can see the whole scale item here. There are items like I feel motivated to learn new things in school. I am usually bored in school. That would be a reverse scored item because that indicates low motivation. I hope the information I learned in school is something I will remember my whole life. I don't feel that things I learn in school will be used later in life. Again, that's reverse scored. I go to school to become a more competent person. I'm okay with getting average grades. That's reverse scored. Building meaningful relationships with my professors is important to me. Talking to my professors isn't essential to my life. Reverse scored. Doing well in school boosts my self-esteem, and my grades in school do not reflect my personal life. And so as you can see, every other item in here is reverse scored. So one thing I like to do before I even put this into StatCrunch is to mark anything that needs to be reverse scored. Meaning, since these are all in 1 to 5 scales, a 1 means strongly disagree and a 5 means strongly agree. For these, I actually want to flip the scale so that a 5 out of 5 always means high motivation and a 1 out of 5 always means low motivation. So to mark these, I'm just going to change the title here with an uppercase R to indicate that these need to be reverse scored. And so that when I enter them into StatCrunch, I can very easily see all of these and then reverse score them. And so your scale might contain no reverse scored items or might contain a few reverse scored items, but basically any item that's the opposite of what you're trying to grade or trying to measure is going to be reverse scored. So after I do that, I'll go ahead and save this file. I'm going to just save it on my desktop. And now you can go ahead and import it into StatCrunch. So I'll go to StatCrunch, select a file on my computer, and then I'll select this demo file. The only other thing to do here is to say share with everyone, yes, just in case you want other people to be able to see it, and then go load file. So for this one, as you can see, it's going to look a lot like the one in Excel. We have all 10 of the items here with their scores, GPA, race, age, and gender. And the first thing we have to do is take care of these reverse scored items. So there's a simple little trick for doing reverse scored items in which you can do a little bit of a mathematical equation to flip these. I'll show you how. So first, we're actually going to change these a bit. So go to Data, Compute, Expression. Because we're going to be computing, we're going to use a little bit of math, and we're going to use an expression to do that. So first off, let's go ahead and build that expression. We're going to start by taking this item right here, and then the first thing we're going to do is times it by -1. So to do that, hit the times button, and then parentheses, type in -1. And then, since this is on a 5-point scale, we're going to add 6 to it. You add just one more past whatever the scale is. So since it's again a 5-point scale, we're going to add 6. So what this does, let me give you a little example here, is let's say that someone put a 1 out of 5 on this scale. What it's first going to do is going to switch it into a -1 and then add 6 to it, which is going to make that into a 5. So in other words, it's going to take a 1 and flip it to a 5. Let's say someone answered a 5 out of the 5. What it's going to do there, again, is going to switch it to a -5, add 6, and that's going to flip it to a 1. So what it's doing is it's flipping the scale. It's going to take 1s, turn them into 5s, 5s, turn them into 1s, and everything in between. If you had a 2, it'll turn into a 4, a 3, it'll just remain a 3, and a 4, it'll flip it into a 2. So this equation works very well for flipping any scale. If you had a 4-point scale, you just want to add 5 at the end. That's the only thing you'll change. If you had a 7-point scale, you'd want to add 8 at the end. So once you're done with that, click OK. And then we're going to want to give this column a new label. And I like to give it the exact same label as before, but without the uppercase R. So we'll go ahead and just do I am usually bored in school and hit compute. And basically it'll input it right there. So then you just want to do that for all of these items. What's nice is if you go back to data, compute, expression, you're going to still have this equation right here. What I like to do is just sort of copy this last part, click build, then you can delete all of this and just do it with a different column. So here we'll go the second one and then paste that expression in there. Oh, actually it doesn't work. Never mind, you can't paste it in there, I guess. So I guess you just have to do times -1 and again, plus 6. So I'll go ahead and do that for all of them and skip ahead in the video. So now we have all of the items we need. We have all the original items, and then here at the end are 5 items that I've reverse scored, meaning that now for all of these items, a 1 out of 5 means low academic motivation, and a 5 out of 5 means high academic motivation. What you might want to do now is actually just delete these reverse scored items, because you're not going to need them for any part of the analyses after this point. So if you want to delete these, you can go to Edit, Columns, Delete, and then just select all the ones you want to delete. I'm just going to select all the ones that start with an uppercase R, because again, we won't need these going forward, so we might not want them to confuse us. So now we're back to just 10 items, but now all of them are pointed in the right direction. 5 mean high, 1 meaning low. So after we have that, now it's time to get started sort of creating an independent variable out of all of these items. So for right now, we have 10 items measuring academic motivation. What we want to do is compile all these into one single variable that's just going to stand for the sum of someone's academic motivation. So what I like to do is just add them all up and divide by the total number. In this case, we have 10 items, so we'd add up all these items and divide by 10. That'll create an average academic motivation number, a 5 meaning really high academic motivation and a 1 meaning really low academic motivation across all 10 items. So to do that, once again, we're going to go to Data, Compute, Expression, and this time we're just going to simply add them all up and divide by 10, but first you need to put in parentheses, so that when you add them all up, you're going to add them all up first, and then out of parentheses divide by 10. So we'll add in all of these with a plus in between. This will make for a very lengthy equation, because these are very long labels. And just make sure you do hit that plus key in between every single one. And at the very end, go ahead and tap to the right so you get out of the parentheses and just do divide, and the total number of items we have here is 10. So click OK. This is going to be kind of hard to read, but if you want to scan through and make sure you did it right, that's fine. But go ahead and just hit compute. And basically, if on this end, they're all 1 to 5 or 1 through 5, then you did it correct. It'll also show it right here, which might be an easier thing to read. So basically what we did here is we created an average scale score. So here, instead of being this long equation, I'm going to just change this to academic motivation. That way it's one item that basically represents all 10 of these items. Now, if this were your dependent variable, you could stop here in your transforming of it, because you have basically one variable that says how much academic motivation each participant has on a 1 to 5 scale. But for this one, it's actually going to be an independent variable, because what we're going to look at here is 2 groups, those who are high in academic motivation and those who are low in academic motivation, and see if they actually have differences in GPA. So to do this, to split up into 2 groups, you first need to figure out where is the average in this. What's the average academic motivation score, so that those who fall above the average can be high in academic motivation and those who fall below it are low in academic motivation. So to figure out an average, you go to Stat, Summary Stats, Columns, and we're just going to scroll all the way down and look at academic motivation. The only thing we need is the mean. So if we click Compute, here's our magic number here, our cutoff. It's going to be 3.48. Make this a little bigger here. So basically, right around 3.5 is the average academic motivation. So everybody who falls above this is going to be in the high group. Everyone who falls below this is going to be in the low group. So the only way to do this really is to create a new variable. We'll call it academic motivation high v low, and then go through this and label them high and low. I know it's kind of a bummer that you have to do this by hand, but there's really no better way to do it in StatCrunch. So here, I'm just going to label the ones low first. If you want to make this a little bit quicker, you can copy this and then just kind of go through, and each one that is below a 3.48 is going to get low. So I'm going to go ahead and do this and then speed up, and then I'll catch you once I'm done. So now that I've done all that, this would probably be a good time to save your data. Make sure you have all this. Of course, you can do that by going Data, Save, and then saving it. Right now I've saved it as Data Computed, just so I know that I have already made all these high and low. So basically the point of all that is to first get all these scale items encapsulated into one item, here academic motivation. And then since this is our independent variable, we have to split it into two groups. So again, I use the mean to split that into highs and lows. Now you can do a simple t-test to in fact see if those low in academic motivation have a lower GPA than those high in academic motivation. So here go to Stat, Ttest, to sample with data. And there we go. Make sure to select GPA here for the dependent variable, because both are going to be the dependent variable the values in. And then click on boxes where we're going to set up our independent variable, which one group is going to be academic motivation equals, and then you want to put in what you actually have here, which is a high or low. And the easiest way to do that is to actually click here and you'll have the two drop down boxes. I'll put in low first. Click OK. And the other one, I kind of misspelled academic motivation. That's okay. And the other one, we're going to make the high group. So academic motivation, add column, and then we'll equal and add high. And click OK. And now here we want to pick what kind of a hypothesis test we want. It has to be directional. And I kind of assume that those high in academic motivation are going to have higher GPA. So right here, basically what I'm saying is that this is going to equal low minus the high. And since I'm assuming the low is going to be a lower GPA than the high, it's like minusing a small number by a big number, which is always going to be less than 0. For example, if you did 1 minus 5, it would equal -4. So since I put the lower number first, I'm going to make this the less than sign. If you were to flip it, make this the high group, and this the low group, then you want to flip the sign too. So I'm going to hit compute, and this will tell me whether or not I have a significant result. And lo and behold, it is significant. So the p-value is at or below a 0.05, so this is significant. We don't know in what direction it is yet. So that's why we want to run, I'll go ahead and close this, but our summary stats to show what the means of the two groups are. So to find that, go to Stat, Summary Stats column, and then we're going to put in our GPA, which is our dependent variable, and we're going to group it by academic motivation, high versus low. And all we want is the in, mean, and standard deviation. And if we hit compute, basically it shows that our hypothesis was correct, that those in the high academic motivation group had a higher GPA of about 2.8. Those in the low academic motivation group had a GPA of about 2.6. So having high academic motivation does seem to have an impact on GPA. And then finally, to make a graph of this, go to Graphs, Means Plot, and then just kind of do the same thing where you select the dependent variable GPA and group it by the independent variable here, academic motivation, high versus low. And then instead of having a multiplier of 2 standard error, we're going to do 1 standard error. And then hit compute. And as you can see, it maps it out here. So it shows basically that those with high academic motivation are having higher GPAs than those with low academic motivation. So there's a nice plot showing our effect. So now to write all this up, basically we've done our t-test, we've done a means plot showing the difference, and then we also have the means and standard deviations of both groups. That's here. Now we can write up our result sentence. So I'm going to go ahead and get rid of all this and just make a new paper so that I can write my result sentence in here. It only needs to be one sentence stating what the result was. So in this we could say it was found that participants high in academic motivation had a higher GPA than those low in academic motivation. And so now we need to go ahead and put in our statistics. So for example, we have the group high in academic motivation. We'll put in their mean and standard deviation. And we want to italicize those because we want to italicize any statistical acronym. And we're also going to need the mean standard deviation of those in low academic motivation. So we'll just put that as a placeholder right there. So as you can see here, the mean for those high in academic motivation had a 2.82. You always want to round to the 100th place, so 2.82. And a standard deviation of 0.65, which you can see right here. We want to round it up to the 100th place. And then right below is the mean for those with low academic motivation, which is 2.61, with a standard deviation of 0.58. So here we've already included a lot of information. One group is statistically higher than the other, and we have the means and standard deviations of both. And then we'll conclude by putting in the t-statistics. So first we'll put in a lowercase italicized t for t-test. Then in parentheses we'll put the degrees of freedom, which you can find right here, df. The degrees of freedom is 233, or 223, equal sign, and then put in the actual t-statistic. And you notice right here we have a negative t-statistic. You always want to report t-statistics as positive. The only reason we got negative is we put the larger group in last. So here you want to make it 2.61. And then for a p-value, right here, again, we have to round to the 100th place. And if we did that, it would actually be 0.00. Let's see, well, this 8 would round to a 5, and this 5 would round to a 1. So it would, in fact, be p equals 0.01. Let's say this was even lower, though. Let's say this was 0.0044. In that case, it would round to 0.000. Basically, if that ever happens to you, if it's that low, then you would just put in p as less than 0.01 because that's as low as you can go. But technically here, since we have the 8 rounding to the 5, rounding to the 1, we in fact would put a p equals 0.01 because it's right on that brink. And then to conclude, we just put in here figure 1 because we're going to put in a figure at the very end. So right here is everything. It was found that participants high in academic motivation had higher GPA, mean and standard deviation, than those low in academic motivation, mean and standard deviation. We have a T for t-test, the degrees of freedom, the actual t-value, always reported positively, and then the p-value. And then for figure 1, what you'd want to do is on a different sheet of paper, I'll go ahead and make a page break here. You want to go ahead and copy this. Find one of the easiest ways to do that is go Options, Copy, and I'll create an image here that you can right-click and say Copy Image. And then right here, you can right-click and paste that image. If it doesn't work initially, go right-click, Paste Special, and make sure Image or Picture is selected. And that should always work. And then add a title to it. You want to actually do that below, and in italicize, go Figure 1, period, and then add some title that makes sense. So you could say difference in GPA between those low versus high in academic motivation. So there you have it, the result sentence and the graph. And you can show both on your poster.